This whole session is based on a real-life project I did for a customer, Electrolux. It's a worldwide manufacturer of household products. And we did an industrial IoT project over there. So connecting all their manufacturing sites worldwide, so really IoT data, streaming it into the cloud with Event Hub, so the real-time processing, all the data stored in Azure Data Explorer, and then the whole Synapse stuff and Databricks to do the big data movements and so on. So a very nice project, and what we need to do was building the foundation, the platform. So other teams could use that platform to build applications and accelerate the digital transformation. So of course, APIs are a very important aspect of that because we deliver as a platform APIs that connect to, for example, ADX to the IoT data, but also to other data sources. And those APIs need to serve as a foundation for the digital transformation over there. This is the wall that we hit quite a few times. We've chosen to implement GraphQL. And yeah, maybe you can see it on my face, but yeah, we've been against that wall quite a few times. So this session is all about sharing my learnings, the issues, the mistakes we made. So hopefully when you do GraphQL in the future, you don't make those same mistakes again. Of course, I'm not allowed to share the internals of Electrolux. So I simulated everything in my fictional company where we have a hotel business. We have multiple countries where we're active in. Every country has multiple hotels, and a hotel has multiple rooms, and so on. So that's just simulating the stuff, but on the real scenario of Electrolux. I'm here on the stage all alone, but behind me and behind that project, there's a really big team. So these learnings are not only from myself, but from the complete team. I'm just the messenger here. So, first introduction, what is GraphQL? It has actually been invented by Facebook to optimize the speed of their mobile application. And when you talk about GraphQL, the focus is mostly on the query language side of things. So it has some important features. The first one is that you, as a client, an API consumer, you ask the data that you need and only that data. So if you only need the name of a certain entity, you only request the name and you don't get the other properties. Compared to REST, with REST you typically get your complete resource. No, here you can just pick and choose what you want, so you don't overfetch data. The second one is that in a single request, API request, you can access multiple resources. Think about Facebook. You open up your web application. You need to get the top 3 friends. You need the total count of friends. You need to get your first timeline data, and so on. So you want to do many resources, many requests in one API call. So that's also possible with GraphQL. Another one, there's a whole type system behind it. So everything is strongly typed, which means that you can generate client software easily with intelligence and these kind of things. I think there are also other big features, but they should, these are the official features on the GraphQL website. You will see some nice goodies later this session. So a little comparison between GraphQL and REST. I found this animation on the internet, which is pretty cool. So imagine that you need to create a shopping basket, and you have a product database or API, a price API, and then also one for the stock. So with REST, typically, the client needs to do all the orchestration. It needs to go to the product API, and then go to the price API and the stock API, assemble all that information, and make it a nice shopping basket to see how many things we have in stock, and so on. With GraphQL, that kind of orchestration is done by a gateway which is in between. So a GraphQL gateway which is in the middle. And you just do, as a client, one call to the gateway, and the gateway will do that orchestration and data fetching for you. And you see it only fetches the data that you requested and nothing more. So this is a little bit more optimized and easier from a client's perspective. Of course, an API which is only query is not good. You need more. So GraphQL has also the concept of mutations. So mutations are just there to mutate the data, so to do your creates, your updates, and send your events. And then a final thing, which is very, very nice, to be honest, those are subscriptions. Subscriptions are actually notifications that are sent through WebSockets. So nowadays, if you click something, for example, your website gets updated. Thanks, we saved it for you. So these typical pop-ups, these notifications, normally you need to use single R, for example, for that and set it all up completely differently. With GraphQL, you get that WebSocket communication out of the box in the standards. Also, API Management supports it. That's why they first came with the WebSocket support, and then later on, that WebSocket support was being used for the GraphQL part. It's already a maturing standard, so big companies are using it, so you will not be the first one to use it. So really nice technology. I'm really fond of it. Definitely if you're building a general purpose platform that you don't know exactly the usage patterns up front, and that was the case for Electrolux. We don't know yet what kind of applications will be built. We have an idea, but of course new ideas will follow. But we encountered some challenges, and those challenges I want to share with you. The first one, of course, a learning curve. Every new technology comes with the learning curve. So we have here already some good resources to start with. So the GraphQL, official GraphQL website is really good. And you see there the hot chocolate thingy. Sounds ridiculous, but it's a very, very good and reliable .NET package, .NET library, which is also Microsoft is supporting that one very well and using it internally. So if you need to build GraphQL APIs in .NET, please go to the hot chocolate website. They're really good. They're really working on the product very hard. So that's an important one. The second one is API design. So you need to create your GraphQL schema yourself. You see it. There's a Visual Studio Code extension for it, but it's quite cumbersome. So at a certain moment in time, you have a schema of 500 lines, and actually you don't know anymore how are these different types related to each other and so on. How can I query from one entity to another one? So it becomes quite cumbersome at a certain time, but luckily there's an open source project, the GraphQL Voyager, that tries to visualize your whole GraphQL schema, and you really see the relationships between them. So let me show that how it looks like. So this is here such a GraphQL Voyager. And let me zoom in a bit, and then you see here the root queries that are available. So I can do countries, get countries by code, hotels by name, the rooms, and a single room with an ID. But if I'm, for example, at a hotel, you see there are quite some relations I can make. From the hotel, I can navigate up the chain to my country, or I can navigate down and say, okay, give me the hotel by room number, or give me all the rooms of that hotel. And when I'm on the room, I can go ask me the room price and the room availability and so on. So you can really navigate through the graph. And sometimes you start with the room, you have a room ID, and then you ask for the room, please give me also the hotel with the name, and maybe give me the country with the name. So you can really pick and pay maybe also what you need. So this is just a cool visualization of what is all possible in your graph. Some lessons learned while designing it. I think the first two are really lessons learned for every API. Think from a user perspective, and in this case, the user is your API consumer. And think outside in. Don't think, I have already my internal database or system of record, and we will expose that exactly to the outside world. No, really think from a functional perspective and choose good naming, no technical names, but really business names, very important. Good naming, I wouldn't say convention, but at least consistency is very important because, every query you just need to give it a name. You see, I didn't put get in front of it. I just said hotels by name. But just make sure it's consistent. If you want to put get in front of it, feel free, but then do it for every query. So just make sure that you have that consistency. Filtering is also important. And there are two approaches to filtering. Or you just specify different queries. User by ID, user by logging, user by email. Or you can also use a generic filter capability that I will demonstrate pretty soon. Also the mutations. We are typically in a CRUD mindset, create, update, delete. But think also actionable. When you create APIs, make them actionable and maybe event-driven. If you change, for example, the capacity of a room, you add a new bed to it, so now it has a capacity of 3 beds instead of 2. You can just call that mutation change room capacity. and not update room and just update the capacity of that room. So just make it more actionable, so maybe also you can plug it in easier in event-driven architectures. So there's a really great YouTube video of somebody, I think it was at LinkedIn, that shares his lessons learned about implementing GraphQL at scale. So let me show you a little bit how the current API looks like. So we go to Postman, and the first query is quite simple. Just give me all the hotels, their name, their city, and the country. And then we navigate also down, and I say, give me also all the rooms, and their floor and their capacity. So we just click the send button, and you get all the information you want. You see? All the rooms, and then my next hotel, and so on and so on. So this is, of course, very nice. On the country, if I want also the country code, there should be some intelligence here. Give me also the country code. And you see we have the name of the country, but also the code. So very flexible. You pick what you need. You have also queries with filters. For example, here I just do the hotels by name, and I can provide a name. So just click send. And we have here the Dune Resort. And if I say, OK, all the hotels with the name hotel in it, probably there will be more. Then you see the Prism Hotel and so on. Again, I only want the name and the city. But of course, do I want to display it on the map? I can have latitude and longitude, for example. Click the send button, and I can display it easily on my map. So you just ask what you want, nothing more, nothing less. And then there are also generic filter capabilities. If you don't want to build every possible action, you can just make a kind of a query builder or filter builder in GraphQL, where you have an OR statement, where the name contains Spa or the city equals Chicago. If you just execute this query, you see we have two hotels. If I make this an AND, then I hope I only get one hotel here, the one in Chicago. So this is more a generic filter capability if you just want to give all the functionality towards others. And then a mutation. A mutation is there to update data or send events. So here I just change my room capacity. I provide my room ID, and I provide the new capacity. And then in the response, you can still ask data. So you can ask the number of that room, even though you didn't provide it in the input. So just select, and you see here we have the capacity just being updated. So now I did an update to my database. One final thing I want to show you are the subscriptions. So those are the WebSockets, so real-time communication towards your front-end application. Unfortunately, this is not yet supported in the Postman client. But if we go here to my API itself, we have here a tool called Banana Cake Pop. That's just the Swagger of hot chocolate, so the Swagger for your GraphQL. So it's just an interface on top of your GraphQL API, and there you can simulate your subscriptions. So I say here, I want to subscribe on the room capacity changed event somehow, and give me of that room the room number and the capacity. I click run, and nothing happens. But you see, it's running. It's now opening a WebSocket, and it's just waiting, like a chat, for messages to arrive. So this is WebSocket communication. This is not API request response. So if I now go to my Postman, and maybe here I do a mutation, I change my room capacity. You see, we have a new message arrived. My room capacity has been changed. So just real time. If I now change my room capacity to 10, let's put many people in it, maximize our hotel room. You see, a new subscription has arrived with 10. So this is really event-driven. And that's what we do at Electrolux. Also, the IoT data that's coming in is being pushed to front ends. So they get live update, a machine goes down, goes through Event Hub and so on, and we push that as a GraphQL subscription towards the front end that gets refreshed and really sees the latest value over there. Of course, we don't send every single event. We aggregate them per minute and so on to make sure that we don't overload it. So pretty cool, this additional functionality, those subscriptions. Scaling across teams was maybe the biggest challenge we had. We had to start with many teams in parallel, and that was not that easy. So if you look at my GraphQL schema over here, we had multiple domain services. I don't want to call it microservices because it was not that detailed, but at least every domain had its own dedicated service and team. So the first one was the hotel catalog. Of course, it was different at Electrolux, but let's say the whole asset management thingy, where you have all the assets described within the organization, was done by one team. Then the hotel pricing was done by another team. So if you are at a room and you ask the price of that room, in the backend you will go to another API. The same for the room availability, a different team that is working on that. And for the sake of the demo, I also stitched in the weather information. So we have the longitude and the latitude of the hotel. I just go to the OpenMeteo API, that's a REST API, to fetch actually the weather information. So you can display that nicely on your website where you are advertising your hotel, which will be in a very sunny period. So different backend services, different domain services, but as an API consumer, you don't see that. So how does it work? That's the concept of GraphQL federation, where you have your client is performing a request to your GraphQL API gateway, and that one is doing all the dispatching with the different microservices or domain services. So that one is smart enough to know this call I have to do first, and the other calls I can send in parallel. It will merge all the responses together and send it to your client. So that's a very smart gateway. I also stitched that together with the OpenMeteo API. We've implemented this completely with Azure Container Apps to have a scalable foundation. Like Tom said, don't start with Kubernetes from day one. Maybe one day we'll need to go to there, but we just start with Container Apps to get started quite easily. And you see the hot chocolate icon everywhere, so everything is implemented with hot chocolate. I wanted to have that GraphQL gateway, that super graph there in the middle. I wanted to build that with API management, but that's not possible yet. Two reasons. API management is still early in the GraphQL story, so they are having a lot of new features coming up over there. Second, the standard is not really a standard right now. So the GraphQL standard is really working. The work group is really working now on this federation thing to get this implemented in a consistent way, because the way Apollo is doing it and the way Hot Chocolate is doing it at the moment is not interoperable. So of course, API management, if they would ever want to invest in this, will only do that when there's a stable foundation that works for every implementation, because they want to be, of course, implementation agnostic. We use Redis intensively. Redis is used for two things. First of all, if one of the domain APIs has a new field, their schema changes. It gets published to Redis, and our gateway gets immediately updated by that. So that's out-of-the-box functionality that's in that hot chocolate graph. And also to do the pub/sub for the GraphQL subscriptions. If you're running multiple instances, you need to have a central pub/sub where those GraphQL subscriptions are listening. So that's also done by the whole hot chocolate package on top of Redis. And then for the sake of the demo, I thought many people would use OpenAI here, so let me do that too. So you've seen it already. We have custom GraphQL resolvers in API management, so you can resolve a custom field. So what I did, I created a resolver in API management, and if you ask from a specific country, the tourist information, we will get and fetch that from OpenAI. So we just ask, give me, this is how that looks like. So if you, on the type country, you request the tourist info, API management will send that call to the policy that you configure here. So it's an HTTP data source. So I say to them, please do a post to my OpenAPI, what is it, GPT 3.5 turbo model. And I set the header to application JSON and so on. And then I make my body, my JSON message to OpenAI. So typically it starts with a system message where you say, OpenAI, please act like a helpful assistant. And then my user message is there at the bottom, where you say, okay, write me a touristic description of the country with this code in a single sentence. So let's have a look in the demo how that looks like. So open Postman again. So here I have my room and room price. So this is my hotel room. I ask the name of the hotel, the number of the room, and then you see I can ask the pricing and the availability. Is this room available in the coming 2 days, yes or no? So we just run this query. And you see you get the information quite fast, 200 milliseconds. And actually you don't see that multiple APIs were called in the back. But in the back, here, we have multiple APIs deployed, all on container apps. Same for the hotel weather information that goes from the Open Meteo API. From a hotel, I ask the weather and give me please the temperature. See, it fetches that temperature. In Belgium, it should be 40 degrees Celsius right now, and in Washington, a little bit hotter right now. And then the last one, the tourist information. So here I have my hotel. Give me the country of that hotel, and then give me the tourist information. So if we execute this, this is really with that custom resolver and API management. It says Belgium, known for its delicious chocolates, waffles, and so on. But if I do the request again, probably we have another tourist information. So you see, it's always a little bit different. Chocolate beer is always returning, of course. That's I don't know why, to be honest, but so pretty cool integration with OpenAI. In the end, it's just an API call away. So observability is quite a challenge. If you look in your logs, you will see this. GraphQL is a single endpoint / GraphQL. It's always a post. You actually don't see what happened under the hood, so that's a problem. So if we configure application insights for this query, you see the colors are referring to the different domain APIs where the data is coming from. By default, application insights looks like this. You have first here your API management. Here. Then we have our supergraph. That's the orchestrator in between, the GraphQL gateway. And then we have the 3 domain services like this. So this is good. At least you see which domain services were tackled, but you don't know what happened under the hood. So if you want to do that, please configure OpenTelemetry in your hot chocolates. So add just the hot chocolate OpenTelemetry instrumentation there and configure application insights as the sink, as the destination for your logs. And then what you get is a little bit more better, I guess. So here you really see the name of the query. And if you would click on that, you see all the details of what has been requested. And then see here that the room availability, room pricing, and the hotel weather was requested. So here you see even the OpenAPI stuff. And here you see that my SQL database was also called. So if you click on that, you will see also the query that was executed and so on. So this is much better visibility. So think about it, because yeah, that GraphQL gateway is somehow a black box. And you need to, of course, see how it acts on the wire. Application map, fantastic thing. Also here you see all the dependencies. So the requests are coming in from API management, sent to the supergraph. And that one is orchestrating between the different domain APIs, of which one domain API here, the catalog, goes to its own SQL database. And this is here our Meteo API that is also visualized. So very good to see the dependencies. You can filter that out, so cool stuff. Next challenge is error handling. What did we have? We had an unexpected, unhandled exception at our hotel, what is it, pricing? Yeah, hotel pricing stuff. So by default, what happened? The exception bubbled up to the client, and it just got also an exception in HTTP 500. Of course, this is not nice, because yeah, the other 2 API requests went well. So maybe we should be able to return that information and just say, OK, we were unable to give you the pricing information. Yeah, those are the logs that you see. There was an exception at the bottom, and it just bubbled up to our API clients, which you don't want. So as a result, we implemented a custom response formatter that made sure that we returned an HTTP 200 instead of an unhandled exception. And that made sure that our client also got an HTTP 200 with all the data that we were able to fetch, except the pricing data. So this is how the response looked like. First of all, an error segment with the error that happened on the pricing API. But you see, all the other data was returned except the pricing, which we made in NULL in that case. So you see also in the logs something went wrong. You can investigate, but the API consumer still got all the data that we were able to retrieve. So that's really nice, because the app will be able to show all the information except the pricing, because there we had an issue. So think about it. Performance, mostly the biggest challenge in GraphQL, together with security related to it. You give a lot of power to your consumer, so you need to make sure that you're ready to tackle those queries. So if we do, for example, a hotel by name, and we ask for all the rooms, the price. By default, what do? You write a resolver for your price. You say, here I have a method, get the room price, and you give the ID, the room ID. That's how your resolver works. So by default, the request will go to your GraphQL gateway. It will first fetch from your catalog all the rooms for that hotel. And then it goes in batch, so it sends one big request to the hotel pricing that asks you, here, give me the price for these 5 rooms, for example. But if you just implemented the resolver, it will call individual methods in your backend towards your API. In my case, I just did a get on Google just to simulate some stuff. So this is how it looked like, my logs, and actually they go way beyond the bottom of my screen, but you see I go multiple times to Google to get my price of my hotel room, you see? So this is not the intention. Luckily, the GraphQL gateway is smart enough, they do it all in parallel, so you don't actually see that it is slow, but if you look in the logs, it did maybe 50 calls in parallel to your API or database or whatever your data source is. So you can improve that with data loaders. In data loaders, you will batch those individual resolver requests into one single request to your backend, your database, or your API, whatever. So it will be much more performant in that way. So here you have one big batch towards your Google instead of having multiple individual requests in parallel. Bear in mind that this functionality is not available in API management. So the customer resolver functionality in API management, if you would ask 100 tourist information of 100 countries, it will do in the back 100 parallel API calls. So that's just good to know. With the data loader, you see that the logs are much more improved. We ask for 6 hotel rooms the price, but we went only once to our backend system. So big improvement. Then security, of course, Nino talked also about it already, very important. For that, we use API management. We use Azure AD. Don't implement your own Active Directory, your own identity provider, just use one that you have already. And all the rest, we handled actually the trusted subsystem. So we just locked those APIs, those backend APIs down on the networking level. So API management is the only one able to call our GraphQL gateway, and the GraphQL gateway from a network perspective is the only one that can talk with the other domain APIs. So we went to Azure AD, configured different roles. So here I just did the hotel pricing reader-writer, the hotel booking reader-writer, the hotel catalog reader-writer. So if you want to change something in the hotel catalog, you need to have, of course, write access. And then there's a nice policy, API management policy, that can validate your requests. And what it does actually, it has a look, what do you want to do? And do you have the required roles claim for that? If you don't have it, we will reject your request. So let me zoom in a bit. So first, I explicitly allow all the query types. So if you want to ask some information about a hotel, you need to have the hotel catalog.read role. It doesn't matter if you do it to the get hotels or you have a room where you ask the hotel information. From the moment you access the hotel type, you need to have that claim. The same for the country, the room price, and so on. And then also all the mutations should be listed over there. If you want to do this mutation, you need to have that role. Same for the subscriptions. If your thing, your query, or the query type or the mutation is not in the list, you will be blocked. That's to avoid that somebody in the domain API will add a new type. It gets automatically propagated into API management, and it's not secured. So here we have a real security gate that explicitly it needs to be added in our API management policy, where you explicitly say, okay, if you want to access that type or execute that mutation, you should have this role. And maybe we need to introduce a new role, but in that way we are sure that not by accident data gets out of the way in an unsecure way. So let's have a look at that. So I'm calling now a v2 of my API management, which is being secured. So I don't have an access token in this request, so I just get an unauthorized. So let me first grab an access token. So this is just Azure AD client credential flow. So nothing special there. You can see my client secrets. I will rotate it anyway. No, everybody says that, but nobody does it. And we use the token. But first, let's look into the token, like here. Yeah, like that. You see here my roles. I currently have hotel weather read, catalog read, and hotel booking read access. So those are the roles that API management will validate on. So if I now perform my call, and you see in the call, I do simple stuff on the stuff that I should have access to, I get my information. But I don't have hotel pricing rights, so if I go to the pricing, and I ask for the price, I don't have access because I try to access the price, but I don't have the required claim for that. So we're safe. The same, but I will not show it again, but if I would do a write, one more. Come on. Get a new access token, proceed, use it. If I want to do a mutation here, because this is a change room capacity, it says I'm also not authorized because I don't have the right role over there. Request throttling, it has been talked about already many times. Does it still make sense in GraphQL? Yes, on one hand it does, because it's still some protection. But also inside one request, you can do a shitload of things. So you need to go beyond just request throttling. API management gives you the option to validate the query depth and say, okay, you can go a maximum of X levels deep in a query. Because you can go to rooms, hotel, country, hotel, room, country, and so on. So you can do endless loops somehow. So with API management, you can just say the level of nesting, you can limit that. With Hot Chocolate, you can go even further, and they have a complete scoring system where you say, okay, one field is 10 points, a custom resolver is 20 points. You can just customize that. And you can say, okay, the maximum query complexity of the queries that I allow should be 1,500, for example. It does the calculation for you. If the query is too complex, they will say, you're not going in. So just this query depth validation in API management, very simple. You've seen it on the policy, it's just the maximum depth that you configure. I think I'll need to authorize because it's the V2. Just refresh my token. The query is too nested to execute, its depth is more than 5. So here you see what I do. I get the hotel, the rooms, I go back to the hotel, back to the rooms, back to the hotel, to the country. So I go really nested. It's too much. API management blocks me. So you need to protect yourself against excessive queries. That's really the key. But sometimes you have your protections. Sometimes some of your API consumers, typically internal consumers, they need to do complex queries. They need to have one maybe very complex query. Then you can use the concept of persisted queries, where your queries are a little bit like stored procedures. They are stored on the server side. They are approved. So you check them with your team, and your team knows, yeah, we can handle those well. And you can also grant access to those persisted queries. In that case, you don't need to send the query yourself. You just reference to the query ID, like you would execute the stored procedure. You just have the name of the stored procedure, and it gets executed server side. So in this way, you can allow still complex queries, but they are validated by your team, and they are governed centrally. And you can put security on it. You can say only our own internal clients that we trust have access to those persistent queries, all the rest not. This is not available in API management. It is in Hot Chocolate. So another challenge is that it's a single endpoint. So with a WAF, for example, a web application firewall, you sometimes get into issues. Remember with the REST API, what I often had is when you had some wildcard search functionality, sometimes that's being blocked by a WAF because it's SQL injection alike. And then what they typically do, they change the rule set of the WAF, but only for that particular operation. If you now have such a wildcard search in your GraphQL API, they need to disable it for your complete API, because those rule sets are applied on a route. And your route is always the same, API/GraphQL. So that's a pity. You can't have differentiating rule sets per operation, you apply it on the complete API. The same thing for network segregation. So sometimes, we say parts of our API, we will move it on the external internet, on public internet. The rest remains internally. This is not possible. You cannot split a GraphQL API somehow with an external and internal part. No, it's all or nothing. The ecosystem is also a challenge. GraphQL, luckily, Azure and Microsoft are really betting on that. So if you need to build an API yourself, and .NET is your most familiar code base, I would say go for Hot Chocolate. Manage it with API management. You can also augment it with some custom GraphQL resolvers, but know that it doesn't use data loaders under the hood, so it might get a performance issue one day. And be aware the Watch API management team and their announcements quite good because they are heavily investing in that GraphQL standard. Also have a look at the data API builder that was announced at Build. That's actually a container that you just need to configure, and it generates for you an API, a REST API or a GraphQL API, you can choose, on top of your SQL database. So that's very nice if you need to have read-only APIs. They just get generated, and it goes. You can have quite some control. You can also do auth security and all on top of it. So if you want a really fast time to market, definitely have a look at this. Personally, I will not use it for update actions because then you typically want business validation to be injected, and that's not possible. But if you just need get query functionality on top of your database, I think it's quite valuable. And it even allows you to change the names of your fields and so on, so it's very, very flexible. So the client-side adoption is growing, but it's still, of course, less popular than REST. So you see, but it's still on a rise, GraphQL. One example of this is the Power Platform. The Power Platform supports OpenAPI. It doesn't support GraphQL. So at Electrolux, we wanted the Power Platform also to consume our asset management. And there we use some API management policies then to make a part of the GraphQL API available as a RESTful service, so the Power Platform could consume it. So bear in mind, the world is all organized around REST. GraphQL is coming, so make sure that you take that into account when you decide to go for GraphQL, that your client-side support is gradually growing, but it's not there yet. So as a conclusion, I'm very happy that we've chosen GraphQL. Definitely, if you're building a general purpose platform, I wouldn't do it just for the backend for front end. I think it's too much complexity, but if you're building a broad platform, it might be good. Really, the real-time functionality, the subscriptions that you just get, WebSockets notifications is really nice. You can easily run it on Azure. You can use any compute service for that. Container apps is my new favorite one. Manage it with API management, and if you build it yourself, or go with the data API builder that does it automatically for you, or have full control with Hot Chocolate. Think about the learning, so if you would implement this, maybe watch this session again, so you don't hit the wall like I did. So don't hit this wall again, and just enjoy GraphQL Paradise. That's my message. All the code is on my GitHub. If you're interested, also follow my blog. A lot of API management stuff, integration stuff in general, and also some GraphQL things. So thanks a lot for being here that early in the morning. And if there are any questions, I think I'll have to take them offline. For the timing, it would be better to take them offline. Thank you.